Good morning. Today we're going to talk about simplifying radicals. Alright? So before you begin, you need to try to memorize the perfect squares from 1 to 15. Alright? So a perfect square is found by multiplying a number by itself. For example, 2 squared is 2 times 2, which is 4. Or 3 squared is 3 times 3, which is 9. 4 squared does not mean 4 times 2. It means 4 times 4, which is equal to 16. Okay? The exponents tell you how many times to multiply that number by itself. Similarly, when you cube a number, when your exponent is 3, you're multiplying that number times itself 3 times. For example, 3 cubed is 3 times 3 times 3, which is 27. Or 4 cubed is 4 times 4 times 4, which is 64. What I want you to do now, I know it's up on the screen right now, but fill out the chart below and try to memorize these values. Okay, they will be very helpful. And these are your perfect squares from 1 to 20. And then your perfect cubes, 1 to 6. Right? So it might be beneficial for you to pause, come back to it, and see do you get these same values. Right? And you can put these right in your calculator. So if you got these values for your perfect squares, you're absolutely right. 1 times 1 is 1, and so on. 15 times 15 is 225. Right? So these are your perfect squares from 1 to 20, and then your perfect cubes from 1 to 6. Right? So, example number 1. Sometimes you're given a radical with a perfect square inside, and these are the easiest to simplify because you're just simply going to take the square root. So because you just need to figure out what number times itself gives you the number inside the radical. For example, if you're given radical 16, notice that the number inside the radical is 16. 16 is a perfect square. So we know that 4 times 4 is 16, so the simplified version of radical 16 is 4. Alright? So, why don't you go ahead and try the next few? I'll cover them up. I know you already saw them, but again, you might want to pause the video right now at this point, fill in those, and then let's come back and check your work. Okay, welcome back. So, you see that square root of 36 is like saying 6 times 36 is 6 times 6. It's a perfect square. So square root of 36 is 6. Radical 100 is 10. Radical 49 is 7 times 7, so 7. 144 is 12 times 12, so radical 144 is 12. And radical 64 is a perfect square, is 8 times 8, so radical 64 is 8. Alright? But if you flip over and turn to example number 2, sometimes you're given a radical that does not contain perfect squares. And these aren't really difficult to do, but it does involve a little more work because we don't have a perfect square, so how do we simplify it? Well, there's 2 methods. We're going to look at the tree diagram method, and then we'll look at the largest perfect square method. And the good thing about this is you'll be able to pick which one you like the best. Okay? So, for beginners, sometimes the tree diagram is the easiest way to approach this problem. You need to find the factors of the number in the radical. You keep finding factors until you reach a prime number. So let's see what that really means. So if I have radical 72, I know that 72 is 9 times 8. I'm going to keep breaking these factors up into smaller factors until I get prime factors. So 3 is a prime number, 2 is a prime number, and 2 is a prime number. I cannot break these up anymore. Alright, so my next step is Notice that all the numbers at the end of the branches are prime numbers. This means that we are done. Our next step is to circle pairs of the same number. Okay? Because if I have pairs of the same number, that means I have a perfect square. Exactly. So, here I have 3 times 3. There's a pair. And I also have another pair of 2's right there. Okay? And then I have 1 2 out by itself. So our next step is to circle our pairs, and we did that only using numbers at the end of the branches. If a group is circled, you write one of those numbers outside the radical, because that's like saying the square root of 3 times 3 is 3. The square root of 2 times 2 is, this is 4, so this is 2. Now if you notice, I have one number here that didn't have a pair, and that has to stay under the radical. Okay? So we circled a group of 3's and 2's, so the 3 and 2 come out of the radical. The other 2 have to stay inside. Next we're going to multiply the numbers on the outside, and I get 6. If I had numbers under my radical, I would multiply those. I do not, I just have a 2. So my answer is 6 radical 2. Okay, the other method that I wanted to show you, and we'll look at a couple of examples of both again, is the largest perfect square method. Now this is another method which might be a little more challenging, requiring you to find the largest perfect square that divides evenly into the number inside the radical. So what I want to do for this one is I want to write down my perfect squares, at least a few of them. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. These are all perfect squares. 16 is a perfect square. Next is 5 times 5, which is 25. 36 is 6 times 6. 49 is 7 times 7. 8 times 8 is 64. And I'm going to stop there. All right? I'm going to look at the same radical. Okay, so radical 72. So now, I want to find a perfect square that's a factor of 72, the largest perfect square that's a factor of 72. So I know that any prime factor, a perfect square over 72 is not going to work, because any number bigger than 72 is not going to be a factor, right? So the highest perfect square factor below 72 is 64, but 64 does not go into 72 evenly, so it's not a factor. So I'm going to go to the next one. 49. 49 is not a factor because 49 times it doesn't go into 72 evenly. 36. Does 36 go into 72 evenly? It does. So I can break up a radical by saying what times what gives me that radical. So radical 36 times radical 2 gives me radical 72. Now I'm going to look here. 36, is 36 a perfect square? It is. So what's the square root of 36? 6. Okay, so I can replace the 36 with 6. 2 is not a perfect square, so 2 stays under my radical, and we're done. Okay? Notice that both methods get you the same answer. So you can use whichever method you find easiest. All right, let's look at another example. Let's look at example number, another example on the next page. Okay, we're going to look at 2 ways because I want you to have options of which way you like best. Alright, so let's look at radical, find my notes. Let's look at radical 32. Okay, I'm going to use the tree diagram, so I know that 4 times 8 gives me 32. 4 times 4, not 4 times 4, but 2 times 2 is 4. I can break this up into that. 8 is 2 times 4, and then I can break this into 2. So 2 is a prime number. This is a prime number. That's a prime number. So all of my branches are they're broken down into prime factors. So my next step is to see if I have pairs. Got loads of pairs, right? I've got a pair of 2's here, another pair of 2's. Then I have a 2 that doesn't have a pair. So 2 times 2 is like saying the square root of 4, so a 2 comes out of there. Here's a pair of 2, so another 2 would come out. What's left under my radical is a 2. So this simplifies to 4 radical 2. And we're done. Okay? Now I'm going to use the largest perfect squares. Again, I'm going to look at those. I'm going to look at radical 32. I'm going to look at my perfect squares. I'm going to put them over here just to remind myself. And if I went here, that's too big, so I know it's not going to be anything else. So I'm going to stop there. Right? 36 does not go into 32 evenly. 35 does not. 16. Whoa, wait there. 16 does. 16 times 2. So this is like saying radical 16 times radical 2. 16 is a perfect square. What does this simplify to? Absolutely, it simplifies to 4. Can it simplify anymore? Radical 2 is to a perfect square? It is not. So my answer, simplified, is 4 radical 2. Let's look at one more together before we move on. And I've already started this one down here. And I have radical 150. Oops. Let me get another piece of paper here. So 150, I can break it into saying 10 times 15. I can break my 10 into saying 2 times 5, 15 into 3 times 5. These are all prime numbers. I'm looking for a pair. I have a pair of 5s, and I'm showing you here a pair. So a 5 would come out. What stays under radical? Absolutely, the 2 and the 3. What's under the radical, I can multiply together. So the 5 comes out, 2 and 3 stays under, so I get 5 radical 6. Okay? Let's look at radical 150. I'll put it down here so it's closer. And I'm going to break this up. I'm going to remind myself about, you know what, let's make life easy. I'm going to show those perfect squares again, if you can see. Alright, so I know the 100 doesn't go into 150 evenly. 81 doesn't, 64 doesn't, 49 doesn't, 36 doesn't, but lo and behold, 25 does. 25 times what gives me 150? Absolutely right. 25 times 6. Okay? Square root of 25 is 5. And the 6 will stay there. So as you can see, again, simplifies to the same thing. So it's totally up to you what method you like best. For homework, you've got some to try. See what you can do with those, and we'll come back tomorrow. Have a good afternoon.